So let's take a look at linearization problems. So to give a basic introduction, let's say we have the function y equals x squared. Just a rough drawing here. And we have the point x equals 2 and y equals 4. To find the linearization, it's basically asking for the equation of the tangent line at that point. So starting with number 1, it asks to find the linearization, and another way to write linearization is just L of x. So find L of x for y equals the natural log of x plus 1 at the point where x equals 0. So when you find linearization, you need to find two things. You need to find the coordinate, the x and y coordinate, and you need to find the slope at the given point. So the easiest way is to start with the x and y coordinate. So we already have the x and y coordinate of x equals 0, right? So we can put 0 here. We just need the y coordinate. And in order to find the y coordinate, all we have to do is plug it into the original equation. So if I were to plug in 0, so then f of 0 would equal ln of 0 plus 1. ln of 0 plus 1 is ln of 1, and the natural log of 1 is equal to 0. So we have the coordinates 0, 0. Now, in order to find the slope at the given point, we need to first find the derivative. So if f of x equals the natural log of x plus 1, then f prime of x, remember the natural log, in order to find the derivative of the natural log, so we have the ln of u, the derivative of the natural log of some function is going to equal u prime over u. So if u is equal to x plus 1, u prime, or the derivative of x plus 1, will be 1 over u, which is equal to x plus 1. So that's our derivative. And now we need to plug in x equals 0 into our derivative to find the slope at the given point. So f of 0, or f prime of 0, my bad, is going to be equal to 1 over 0 plus 1, which is 1 over 1, and our slope is going to be 1. So I'm just going to write m, where the slope is equal to 1. So now what we can do in order to write the linearization equation, we just need to use our standard slope-intercept formula. So we do y minus y1 equals the slope times x minus x1. So we already have our x1 and y1. That's our standard coordinate, which is 0, 0. So we can do y minus 0 equals the slope, and the slope is equal to 1, equals 1 times x minus x1, and our x coordinate is 0. So then y equals, y minus 0 is y, and we have 1 times x minus 0, which is just x. So you can say y equals x, or you can say the linearization function, so L of x equals x. So number 2 asks to find the linearization for y equals inverse cosine of x, or arc cosine of x, at the point where x equals 0. So obviously we have to find our coordinates first, and we're already given the x coordinate of 0, as shown here. So in order to find the y coordinate, we can just plug it in to the original equation. So we get y equals the inverse cosine of 0, and I just need to think about cosine of what degree gives me 0, and that would be the cosine of pi over 2. So y is going to equal pi over 2. So our coordinates are 0, pi over 2. And now in order to find the slope, we just need to derive y. So we get y prime, and the derivative of cosine x, remember, or inverse cosine of u, is going to be equal to negative u prime over the square root of 1 minus u squared. So if my u is going to be x, then we have the derivative of x, which is 1, so negative 1 over the square root of 1 minus u squared, so that would be x squared. So now that I've found my derivative, I can plug in the x value of 0. So let me do that. you get negative 1 over the square root of 1 minus 0 squared, which is 0. So we get negative 1 over the square root of 1, which is 1. So then the y prime of 0 is going to be equal to negative 1, which is our slope. So now I can put all that I found in point slope form. So y minus y1, so our y coordinate, pi over 2, equals the slope, negative 1, times x minus x1. Our x coordinate is 0. So if I were to simplify this further, you get y minus pi over 2 equals x minus 0 is x, and negative 1 times x is negative x. And when I add the pi over 2 over, y is going to equal negative x plus pi over 2. And if I want to, I can replace y with L of x as a linearization abbreviation. So we get negative x. L of x is equal to negative x plus pi over 2. And that is the equation of the tangent line at the given point of x equals 0.